Good morning, and welcome to the next part of this lecture series on Chapter 1 of Hands-on Virtual Computing, which we are using for our server virtualization course. I've talked about the overall objectives for Chapter 1, and if you haven't done it yet, read Chapter 1, front to back, word to word, in its entirety. It really is a broad overview of the entire course, as the Chapter 1 of Cengage book usually is. We've talked about what virtual machines are, about software virtualization. We've talked a little bit about how virtual machines work in reference to Type 1 versus Type 2 hypervisors. Now we're going to start talking about how they work in terms of the software and the hardware requirements. Every hypervisor must provide hardware resource access to the VMs. That's their whole purpose. And it usually has to do that in a way that allows, particularly if you're talking about Type 1 hypervisors, say an ESXi host or a Hyper-V server, which is running lots and lots and lots of VMs, it's not, it has a limited number of particularly CPUs. In terms of your memory and your hard disk space, you kind of can accommodate you kind of figure out, okay, how many can I support at once? It's kind of the same question with your hypervisors as well, in terms of the CPUs. But really and truly, each of those VMs thinks it's got at least one CPU all to itself. And you probably obviously don't have 20 or 30 separate CPU dies on the board. The PowerEdge 630s in Room 220 have two slots. Those dies might have, I think they're quad cores, so they could, from a certain point of view, if you've got both of those slots populated with quad core processors, that's actually eight separate CPUs available to your VMs. But what if you're running more? So what the hypervisor has to do is apportion access to the physical hardware resources and relay those through to the virtual machine. So the virtual machine thinks it's got a hard drive that's of such and such size, and so many gigs of memory. It's got a keyboard, it's got video, it's got I/O. And now, depending on whether we're talking about a Type 1 or a Type 2, some of these things will differ. If you're talking about a Type 2 hypervisor, say on a workstation platform, whether it's a laptop or a desktop or a true workstation, that might have a really nice graphics card that the VM is going to have to simulate. If you're talking about a Type 1 hypervisor, say, again, the 630s in Room 220, they only have a couple of VGA ports, one on the front, one on the back, so you can physically plug a console in if you need to. But they don't have the latest and greatest NVIDIA or ATI graphics, because that's really not their purpose. So the hypervisor has to, it's a lot like the OS managing hardware access for all the programs that it's running, except that the hypervisor is doing that at another layer of another degree of abstraction, because it's doing that preemptively multitasking for multiple virtualized operating systems. So what the hypervisor does is that it intercepts and it processes those requests coming out of the guest OSs, takes those, captures them, and then feeds them down to the host OS. Where this gets really fun is the hypervisor has to be smart enough to turn a guest OS function call, system call, kernel invocation, whatnot, from one kind of operating system to another. Say, if you're running a whole bunch of Windows Server or Windows NT VMs on top of Linux, or a whole bunch of Linux on top of VMware Workstation 15 on top of, in my case right here, Windows 10. there's a whole lot of differences in how those OSs work internally. And the hypervisor is completely obscuring all of that. That's why it's really useful to think of the hypervisor itself as an abstraction layer. Um, these VMs, these guest OSs, all have a number of important files. Two of the big ones are your configuration file and your virtual disk. In the case of a VMware Workstation VM, your config file is a .vmx, and your virtual disk is a .vdh or .vmdk, something like that. And usually, depending on how you build the OS, it could be one file or it could be a number of them. Now, if you do that, you have your virtual hard drive split across a number of different files, and you start accumulating snapshots, that directory for that VM is going to get very, very busy, because it'll have one of those for each snapshot for each VM. So, as I said, these can be stored singly or separately. Now, if you store it singly, that may be good for some applications, but not others. So pay close attention to what you're doing. Pay really close attention as you're, particularly say with VMware Workstation, as you're walking through that VM creation wizard, which you should be really familiar with now. And if you're not, you're going to get really familiar with it. Pay attention to the advice it gives you, because a single disk may be better for maybe easier to move but harder for performance, or more troublesome in terms of performance, or vice versa. Now, we can also share our peripheral devices, the NICs, the USBs, etc. Now, the thing about these USB ports is you can only share them with one guest OS at a time. Say, for example, if you take a USB stick and you plug it into a USB port on your host system, VMware will say, "Hey, there's a new USB stick. What do you want to do with that?" It'll ask you, do you want to disconnect it from the host and connect to a specific guest OS, or vice versa? You can actually move it around between them, kind of sneaker net between your VMs while it's still plugged into your host system. But the upshot is you can't actually tell multiple operating systems that they all can talk to the USB at the same time. If the host OS can see it, the guest OSs cannot. If one of the guest OSs can see it, none of the others can, and also the host can't. So other things, however, are shared. NICs. Everything can use the one NIC, one or two NICs that you have. If you've got a server grade system, you might have 4 or even 8 if you slap another card in. They can all use that, and we'll talk about how that works in more detail later. So let's look at let's look at it graphically. So we've got our physical hardware, the host physical memory. All of that is kind of being broken up, being tracked for the purposes of mapping virtual memory to physical memory in what we call a shadow page table. We've got our physical disk, and we've got virtual disks inside of that. We've got VM configuration files inside of that, and those tell the VM the virtual machine how it's going to work. We've got our mouse keyboard input going into both of them. You can tell multiple VMs to pay attention to the same CD drive, or what works for a lot of what we've done is actually you tell the VM that its CD drive is really an ISO file. That works too. So next thing I'm going to talk about is our software and hardware requirements. Thanks. I'll be right back.